Welcome back, YouTube. We're doing Chapter 11, Section 7, How to Solve Nonlinear Systems. All right, so we figured out with linear systems, the elimination method works, and that's where that extension of the elimination method is the Gauss-Jordan and the matrices and all that stuff. But what if it's not linear, a nonlinear system, like 3x minus y is equal to negative 2, and 2x squared minus y is equal to 0? How about we use the substitution method? So this is how this works. Take either equation, pick up whichever one you want, solve for x or y, and plug that information back into the other equation. So how about we solve for y here? I think that would be nice and easy. How about we transpose? Let's add 2 to both sides and subtract y from both, and add y from both sides. Okay, so y is 3x plus 2. What does that mean? I can take what y equals in this equation and plug it into the other equation. All right, so what does that mean? 2x squared minus that is 0. So now look what's nice about the substitution method. We substituted an expression in x for y, and now we can focus on x's. There's no y's. Okay, how do you subtract? Add the opposite, so 2x squared minus 3x minus 2 is equal to 0. Okay, is this factorable? Let's see. Tricky try. What multiplies to negative 4 and adds to negative 3? How about negative 4 and positive 1? So 2x, 2x, and 2. The eyeglass theorem, remember? And negative 4 and positive 1. Now the thing is this. You don't need the 2 to solve, the 2 on the bottom. You can just set those factors in the numerator equal to 0 and get an answer. Clearly, x equals 2 or x equals negative 1/2. But let's make sure this is a tricky try and we did it right. That means the 2 will cancel out. Is the 2 a GCF in the numerator? Yes. The first factor, 2x minus 4, factors as 2 times x minus 2. And then we're going to cancel out the 2 on the bottom. And so the equation, the complete factorization of the equation is x minus 2 times 2x plus 1 equals 0. If you FOIL that out, you should get 2x squared minus 3x minus 2. And what does that mean? Well, x minus 2 is 0, or 2x plus 1 is 0. Okay, so x is therefore 2, or 2x is negative 1, making x equal to negative 1/2. Okay, now what we're looking for is points of intersection, so you're not done. You got to get the y value here and the y value here, right? Well, how do you do that? Well, go back to the top and plug in your x values into any one of these equations, but I would say use this one. This says what y is, right? 3 times x plus 2. Okay. So 3 times x is 6 plus 2 is 8. So there's your point of intersection. And 3 times negative 1/2 is negative 3/2 plus 2 or 4/2 is positive 1/2. So let's list out the points of intersection. And they are x is 2 when y is 8, and when x is negative 1/2, y is positive. Okay, can you check your work? Yeah, you can plug those numbers back into the original equations, but then think about it. You're going to plug in 2 equations into the 2 points. You're going to check those 2 points into the first equation and those 2 points in the second equation. It's really like 4 checks. That's a mess. How about we just do this graphically? So in other words, let's graph y equals 3x plus 2, and let's graph, well, what is this? Y equals 2x squared, right? Okay, let's see if graphically we get those points of intersection. In other words, you're sort of resolving it on the calculator. See if you get the same thing, and that's not what we're doing. Let's get rid of that, let's get rid of that, let's get rid of that. Okay. So the linear part, so it's not a linear system, it's a linear quadratic system in this case. We get the linear part is y equals 3x plus 2. That's mx plus b form, right? Self-intercept form. And then y equals like 2x squared. Okay, good. And I think zoom 4 is probably big enough. If not, we could zoom out or whatever. Make this a little bit bigger for you. So there's your line. And there's your parabola. Okay, so I see already the negative 1/2, 1/2. Let's see. Second trace is calc. Intersect is 5. First curve is blue. Second curve is red. And the closest intersection point to there, I think, is the negative 1/2, 1/2. Let's see. Enter. I don't have to guess. Yep, negative 0.5, positive 0.5. Perfect. The other root was 2, 8. That's off the screen. So let's make the window a little bit bigger in Ymax. Go on. Let's make it big enough to include 8. How about 10? Does it look like 2, 8 is the solution? This is not a square window anymore, but you should see all the points of intersection and all the turning points and all where it's increasing, decreasing these functions and all the intercepts. Yeah, this is a complete graph. Good. So 2, 8 looks good. Let's make sure. Second calc, intersect, Now, first curve is blue, second curve is red. Okay, fine. But I'm nowhere near where I want to be. So I could trace over there, but for some reason it's really, really slow. Why is it so dang slow? So I'm going to type in a guess. It's on the side where x is positive 1. How about that? And boom, 2.8. Perfect. That's it. There's your check. So we got negative 0.5, positive 0.5. Yep. And we got 2.8. Yep. Perfect. Done. All right. What if it's nonlinear, but it's not linear at all? It's not linear quadratic. How about quadratic and circular? All right. How about this? X squared plus y squared is 13. So circular parabolic, you could call this. Quadratic circular, quadratic elliptical, because the circle is an ellipse. All right, so how are you going to do this by substitution? Again, pick whichever equation you like and solve for x or y. Again, I think it's probably easier to solve for y here, right? Okay, so how about we transpose? Let's subtract x and let's add y. Transposition is 2 steps in 1, adding, subtracting, whatever. All right, so what are you going to do? You're going to take what you just got, what y is, plug that into the other equation where y is, and then you're going to be able to solve for x. You can focus on just that. So what do you got? You got x squared plus quantity squared. What is it? Y is x squared minus 7. All right, so you got to FOIL that out. X squared plus x to the 4th minus 14x squared plus 49 is 13. Okay. Now, let's see. Let's get this in standard form so we can factor the quadratic formula, because I think it's quadratic. Let's see. Leading term would be x to the 4th, highest degree term. Combine the x squared terms, negative 13x squared. How about we subtract the 13 from both sides, plus 36. All right, is that factorable? It's not even a tricky try. It's regular trinomial factoring. What multiplies to 36 and adds to negative 13? Well, negative 9 and negative 4, right? But what are you factoring in terms of? X squared, the middle term. But if you use the quadratic formula, it's solving for x squared, right? Because it's a quadratic. If the middle term is based on, it's a coefficient times x squared, the leading term has to be something some coefficient times x squared squared, x to the 4th. Yes, this is quadratic. So quadratic formula works here if you need it. Now be real careful. If you need the quadratic formula, you might get weird radical answers. That's okay. Those are real numbers. But remember, these are points of intersection. The x all the values on the x-axis are real, and all the values on the y-axis are real. So if you ever get I in your solution, or negative discriminant in the quadratic formula, there isn't a point of intersection. Just say so and walk away. All right, but wait, look, you can factor some more. Dots. X plus 3, x minus 3, x plus 2, x minus 2. Okay, so there you go. So be careful. It could be there's no point in the intersection. What does that mean? You're going to get a discriminant which is negative when you solve one of these. With the quadratic formula, that's usually what happens when there's no solution. All right, so look, we're looking for a circle and a parabola. That could be as many as 4 solutions, right? Notice this is a 4th degree equation in x. There's 4 different values of x. So if we set this equal to 0, x could be negative 3, or x could be positive 3, or x could be negative 2, or x could be positive 2. All right, now what's y? Remember, it's points of intersection. You need the y's. Well, y is, you could plug in your x values in any one of these equations you like. But how about, let's plug it into here, because this says what y is, square x and minus subtract 7. Okay. So square negative 3, you get 9. Minus 7, you get 2. Square positive 3, you get 9. Minus 7, you also get 2. Square negative 2, you get 4. Minus 7, you get negative 3. Square positive 2, you get 4. But subtract 7, you get also negative 3. So 4 points of intersection between the parabola and the circle. You could get as many as 4 and as few as 0 if they miss, if there's no point of intersection. You could even get 1, 2, or 3 points of intersection between a circle and a parabola. How do we check this? By the way, whoops, state your answers. The points of intersection are in point format. What is it? Negative 3, 2, positive 3, 2, negative 2, negative 3, and positive 2, negative 3. So there's only 2 possible y values, but there's 4 possible x values. What does that mean? Well, if instead you solved for x and plugged in to x an equation and solved for y first, it would be a quadratic in y where there's second degree only 2 possible solutions. All right, let's check this. So what is y? All right, so what is y? If x squared plus y squared is 13, subtract x squared, you get 13 minus x squared. That's y squared, square root that. You plus or minus 13 minus x squared is the top half and the bottom half. If you're in function mode, you got to split it up because the circle's not a function, right? and then x squared minus 7. Okay, so let's graph all of that and see if we get 4 points of intersection, and in fact the 4 points we just listed. Wake up, wake up. Why did this wake up? Waking up. What happened? There it is. Okay. So, the top half of the circle is, let's clear all of this, is the square root of 13 minus x squared. Okay. The bottom half is the negative that. So I could type it out. I could say vars, y vars, function 1. Or, how about this? You could do this instead. Second recall. Vars, y vars, function 1, enter. We'll type it out for you if you want. And then the other guy was x squared minus 7. And let's make sure I'm doing 4. So this top half of the circle, that's y1. Bottom half of the circle is y2. And then the parabola, y3, is this black thing, which we don't see the whole parabola. You don't see the turning point, but you see all 4 points of intersection. So let's leave it at that. That's fine. All right, so let's say I want the solution in the first quadrant. Second, traces calc, intersect. Now notice it's highlighting the blue curve. Is that what you want? Yeah, the blue curve is part of the intersection point in the first quadrant. It's blue and black. So hit enter. You want the red curve? No. Down arrow or up arrow. You want the black curve? Yes. All right, and then do you have to guess? I guess you could write something in the first quadrant for x. How about 2? It's tracing very slowly, so I usually do this by trace, but it's not tracing well, so I'll just put a guess if it's near 2. And is one of our solutions 3, x is 3 when y is 2? Yes, it is. All right, how about we go clockwise? How about the third quadrant? The fourth quadrant, sorry. I know, how about counterclockwise? Let's go to the second quadrant. Second, calc, intersect. All right, in the second quadrant, it's blue and black. So blue, yes. Red, no. Black, yes. Guess is in the second quadrant. How about a negative 2 for my guess? So it knows, closest intersection point I'm looking for. So I got 3, 2, and I got negative 3, 2. Perfect. Okay. Let's do the third quadrant. Second, calc, intersect. Second trace is calc. Then intersect is 5. And then I want first curve. Well, in the third quadrant, it's red with black. So I don't want blue, down arrow. I want red, enter. I want black, enter. And guess, well, I'm close to that root, so just hit enter. And negative 2, negative 3 is in the third quadrant. Perfect. That's it. And that's one of the answers we got. Right. All right, and then in the fourth quadrant, second, calc, intersect. First curve, let's see, what is it in this fourth quadrant? Black and red. So not blue, down arrow. Red, enter. Black, enter. Now, if I just hit enter here, it's going to stay in the third quadrant because that's the closest root right there. So how about I guess something in the fourth quadrant? X is going to be positive. Well, 2, enter. And 2, negative 3, we got everything. Right, that's it. It's done. All right, so hope that helps, guys, with your homework. There's the solution, by the way. Those were the same points we just got, right? Perfect. Very nice. All right, so what's the homework tonight? Page 784, multiples of 5, just like that. Nonlinear systems. So if you have nonlinear systems, use substitution. Don't do matrices, okay? Tomorrow we're going to do the John Nash theorem. OMG. Remember John Nash? Okay, we'll talk about that. All right, bye-bye, YouTube. Have a nice day.